Uh, Hi, so today I did about, as I said before, I was going to, proceed more into aggregation direction. And first of all, I saw the problem in searching for the document. I mean, for each, this thing, tasks. So we wanted to find all the tasks which had assignee of a certain person. So I appended this method, which is this explain execution stats. So it got me the execution statistics. In this there is a object called execution stats, in which there is a value. So we got to know how many document this find query scanned through in order to get to this assignee. So we want to reduce this number, because if there are thousands of documents, it is 7 right now, but if it's thousands of documents, it will be pretty non-practical. So I created this create index, and put the assignee as 1. And so actually 1 is about in sorting. Like if it's -1, then it sort in descending order, and it checks through the index in descending order. So after that, it just looks for it, and now the number of documents which are being examined is just 4. So after creating this document, I moved on to the next step of the so yeah, we can see as the when we type in get indexes, we can see the indexes. This index is made, and the documents scanned are reduced. So after that, I executed some aggregation strategies onto this database of mine. So here we have it. So let's see, I will call this endpoint because the server is already started. HTTP localhost 8000. So this is the aggregate function which I have made. So this is the first one, to get the distinct assignees. So in this one, we want to group together all the tasks which have the same assignees. So this is what we are going to do. I saved this file, server is updated. Let's see what happens. Yeah, so it gives me 2 entries, which is only because there are tasks such that it only gives 2 there are tasks for just 2 users, as we can see when you go to tasks. Wait, yeah, this is a mistake. Yeah, so anyway, it gives us 2 users because the tasks were only for 2 users. So moving on, we have the filter to short hours and get the assignees from them. So what is happening is that first it's matching that the duration is to be lesser than 5. So why we want it to be lesser than 5? Because because we want to test that only the short duration people are to be filtered through. So these are 2 stages of the pipeline. It groups through all these output from the previous stage, and groups like so that it groups through the assignees. So now what will happen is this. Yeah, of course. Now we head into the next aggregation, which is computing the size of the reporting array. So how to find out the size of the array? We can use such a pipeline. We can do it in 3 steps. So what will happen is we will compute the size of the array in a separate field altogether, and then match it using like this. So it filters only the documents which have the computed field value more than or equal to 2. So after this stage we head to the next stage. The next stage is about projection. So projection, what it basically does, it changes or transforms the columns accordingly. In my case we are just removing this vestigial column because we don't need this column anymore. This was a computed value. So when we write this out and go here, yeah, so we can see that we have found the we have aggregated through the entire thing, and now it gives us the output of this. Yeah, because this is the only, Darth Vader was the only person in the entire users group which has the number of supervisors which are greater than 2. As a sign of proof, I can yeah, so as we can see, Darth Vader has 2 values of reporting. No other person has 2 values of reporting, so they are not in the output. Anyway, going back to my aggregation pipeline, we can comment this out, head to the next stage. So in this one we have to count the number of documents coming in from the previous stage using count. So what I will do is do the same query as the previous one, as we have said that we want to find out the size of the size of the reporting array, and whichever documents have size smaller than 2, we count them. How we want to find how many people have less than 2 supervisors, which means 1 or 0 supervisors, right? So we want to find mid-level senior executives in the organization, if such an organization exists. So let's run this again. Yeah, so we have 3 people who have lesser than 2 advisors, as we can see. So I'm going to comment this again. Boom. Now we go to the move on to next aggregation. So in this we are going to count in each group. So what we are going to do is for each group we are going to sum 1. We could have put a column name here instead of 1, but we are going to sum 1 in each group, so it just counts. That's the basic function of count. That's what counting means. And yeah, so after that, this is just basically a demonstration tool so that we can show that we can also put column name instead of this. So what it does, it accumulates the duration of each task in that particular group. So because it is being grouped by assignee, so for each assignee we are counting the number of tasks first of all, and then we are finding out the total duration of the task which the assignee has that he has to do now. So as we can see, we have this. So yeah, there are 4 tasks for Cyto apparently, and the number of hours you have to work for is basically 19, and there are 3 tasks for Darth Vader, and he has to work for 105 hours. So yeah, that's a lot. He's not going back to model. Anyway, so we move on. We want to find the average of each group. So this is very similar to the count one. It's just that it's a bit shifted. So what we are going to do, instead of sum, we are going to average. We are going to average for the duration. So we are going to keep the sum intact, so we can see what has been divided in the denominator. So for each group we are going to have the average duration. Let's see if it works. Yeah, it works. So as we can see that we have average duration as 4.75 and total number of assignee as 19, and as expected, right? So we have average duration. Cool, let's move on. moving on, we are going to sort tasks duration in ascending order. This will be pretty simple. So what it does is it uses the sort operator. Sort operator basically sorts it. You give it the duration and 1, and it does that. No big deal. Let me save it, and then yeah, so it sorted it. As we can see, there is first of all there is 1, and then there is the duration is then 3. After that the duration is then 99. So sorting has been achieved. We comment this out and move on to the next aggregation. In this one we have to sort and then group. So what we are effectively doing is here is that in each group we have effectively sorted each group. Sorted by what means we must ask, and that is that we have sorted it. So let me explain here that first we sorted it and then we grouped it according to assignee. So what we are doing here in the side is that we are pushing an array into each group. So yeah, for each group we are going to push it into an array called assignee tasks, and such that the entire document gets filled inside that array. So yeah, it's not going to be a flattened out document output. Instead it will be a composite of the objects. It will be a nested object output. Let me show you. Let's see. Yeah, so as we can see, it did the aggregation right there. So yeah, inside each group we have this array. So this is the group about Cyto, and inside this we have assignee tasks array, in which the first one has duration 1, and the second one has duration 3, and the next one has 4. And of course, because we have done the sorting in each group, we are having this increasing order of duration. And similarly in the next group we are having first one has duration 1, second one has 5, I think third one has 99. So it is sorted successfully. Success. Okay, so let's move on to the next aggregation here. So what we are going to do now is going to get top 5 most time taking tasks. So we are having a lot of tasks right now. So what we will do is we will sort according to the duration in descending order in the first pipeline stage, and after that we are going to limit these by 5, so we can get the top 5 effectively speaking. After that we will execute this query, and let's see what happens. Cool. So we have 99 first, and then 11 afterwards, and then 3. So we have effectively got the top 5 things. So we can change the top 5 to top n, and then maybe do descending order. So we have the bottom 5 or bottom k number of documents. So yeah, according to that. So we can of course, the advantage of having a pipeline is that you can append more and more stages. It will take more time, of course, but that's the job. So the next job is we have to use type. So what we are going to do is we will put the type as this operator inside the duration type. So this is a random name which we have given. We could have given anything else. So this is done inside project, because project can change the project can make a new field itself by transforming it from the previous field name. So the previous field we are using it to transform as the input is duration right here, and then the second input we are taking is description. So we are taking the both and calculating both types and finding out the output. So since all the outputs are the same, I think all the types are the same, we have no inconsistency in the data. So if there is some inconsistency, it will show up right here by using distinct by matching it using grouping. Yeah, so of course we can match it using grouping by using two keys instead of one for in the group stage. So if we append a group stage here, we can, of course we can take two keys such that it will find the unique pairs of duration type and description type by just appending to this pipeline as a next third stage. Moving on, sorry, second stage. So the last task here is to unwind. So why will we use unwind? We will use unwind to flatten an array. We often use flatten an array to basically iterate inside of pipelines, but this example I'm doing without any nesting inside of pipeline or anything. So this basically prints out the output of all the users with the reporting. So basically, as we have seen in the data, that Darth Vader has two reporting managers. So what will happen is that what should happen is that the Darth Vader should appear in the user's output twice. So first of all, it will have the first element of the array with its field name, and after that it will have the second element, and so on. So let's test this one out real quick. Here we go. So as we can see we have Darth Vader twice here, and each of the time it's different. Why different? Because first of all it has this reporting E1, and then we have E6 reporting, so that's different. So if we have more items in the Darth Vader reporting array, we could have more elements with this thing. So this concludes the aggregation pipeline playlist. I have completed all the the usual pipelines which are usually there. So the next steps will be, I think, to apply these all of these tools and integrate it with some sort of a Hugging Face LLM model. So I can create basically a full stack sort of AI application through this. So anyway, this is all for today. Catch you in the next one. Bye.